Since hyperbolic functions are defined using exponentials, it is natural to guess that their inverses will be expressed in logarithms. And in this section, we will study the logarithmic forms of inverse hyperbolic functions. First, we have inverse of hyperbolic sine, that is ln x plus x square plus 1 square root, and we will verify that indeed this is the logarithmic equivalent of hyperbolic sine inverse. First, we will take y as our hyperbolic sine inverse. So, what is hyperbolic sine y? Here also we will apply hyperbolic sine. So hyperbolic sine y is, these are two inverse operations of each other, so they cancel. So we are left with x. What is hyperbolic sine y? By definition, it is e to the power y minus e to the power minus y by 2 equals to x. See, we want to find y equals to this one. So from this equation, we will solve for y. You can guess also this will be converted to a quadratic equation. So multiply 2 both sides, we have e to the power y minus e to the power minus y equals to 2 times x. Bring that 2x to left side, we have e to the power y minus e to the power minus y minus 2x equals to 0. And this one is 1 over e to the power y minus 2x equals to 0. Now multiply e to the power y both sides. So here we have e to the power y square. E to the power y cancels 1 minus 2x times e to the power y equals to 0. Now, so this is, let's rearrange the terms. Minus 1 equals to 0. Now this is in a quadratic form in terms of e to the power y. Let's put t equals to e to the power y. So our equation becomes t square minus 2x t minus 1 equals to 0. We will apply the quadratic formula where t equals to minus b plus or minus b square minus 4ac by 2a. Sorry, this is t. What is our a, b, c here? Here a is the coefficient of this one. Coefficient of this one is 1. And b is coefficient of t, which is minus 2x. And c is minus 1. This one. So what is our t? Thus t becomes minus b, minus of this quantity, which is 2x, plus or minus. Then we have b square. Square of this quantity is 4x square minus 4 times a c. So we have plus 4. Then 2a. 2 times a is 1. 2 times 1 is 2. Now, so what is our t? We can take 4 common and 4 outside of the square root. So we have 2x. When 4 comes outside of the square root, then we have square root of 4, which is 2. Then it is x square plus 1 whole divided by 2. Then we can cancel 2 from the numerator. We have x plus or minus x square plus 1. Note, what is t? T is e to the power y. It can be either x plus x square plus 1 square root, or our e to the power y is x minus x square plus 1. Note, this quantity is negative because this is bigger than x. Why? We know x equals to square root of x. If x is positive, let's for now let's assume that x is positive and x equals to, we know x equals to square root of x square. If you add 1, then it becomes less. So this quantity is bigger than x. Therefore this is negative because you are taking out a bigger quantity from a small one. So e to the power y is negative in this side, which can never happen. Therefore our e to the power y is this one. Thus y equals to, we can take logarithm both sides, natural logarithm, which is ln x plus x square plus 1 we are done. Our y, what was our y? Sine hyperbolic inverse. So this is our logarithmic form of inverse hyperbolic sine. Now we have hyperbolic cosine inverse equals to ln x plus x square minus 1 square root. In sine inverse, we had x square plus 1. Let's prove this. We will apply the same trick. What is our y? Y is cosine hyperbolic inverse x. Then our cosine hyperbolic y becomes x. Let's write directly. What is our cosine hyperbolic y? It is e to the power y plus e to the power minus y divided by 2. Let's multiply 2 both sides. We have e to the power y plus e to the power minus y equals to 2x. Bring the 2x to left side. We have e to the power y. So this is e to the power minus y, which can be written as e to the power y 1 over e to the power y plus, sorry, it is minus 2x equals to 0. Then multiply e to the power y both sides. We have e to the power y square plus 1 minus 2x e to the power y equals to 0. So by rearranging, we have e to the power y square minus 2x e to the power y plus 1 equals to 0. Let's apply the quadratic formula directly. We have taken t as e to the power y. So now e to the power y is minus b. Minus b means minus of minus 2x, plus or minus a is 1, b is minus 2x, c is 1. In square root we have b square minus 4ac. B square is 4x square minus 4 times a is 1, c is 1, so it is minus 4. And denominator 2a, 2 times 1, which is 2. Similarly, we can take this 4 outside. By taking common outside of square root means it becomes 2. So we have 2x plus or minus 2 x square minus 1 divided by 2. So it becomes x plus or minus x square minus 1 square root. We can cancel 2 from numerator and denominator. So our e to the power y is x plus x square minus 1, or e to the power y is x minus x square minus 1 square root. Note, this quantity is slightly less than x. So their difference lies between 0 and 1. When you take the logarithm both sides, you have ln x minus x square minus 1 square root. When this quantity lies between 0 and 1, this value becomes negative. But y, that is hyperbolic cosine inverse, can never be negative, because the range of hyperbolic cosine inverse starts from 0 and goes up to infinity. It is non-negative, but here you have negative value. So this case can't happen. So what is our y? So our y is ln x plus x minus 1 square root. This is our hyperbolic cosine inverse. Next we have hyperbolic tan inverse in its logarithmic form, and this is the domain of hyperbolic tan inverse. X lies between minus 1 to 1. Let's prove this. Same, we'll take y as hyperbolic tan inverse. Then our x becomes hyperbolic tan y. By definition of hyperbolic tan y, it is hyperbolic sine y divided by hyperbolic cosine y. What is hyperbolic sine y? It is 1 over 2 e to the power y minus e to the power minus y. This is 1 over 2 e to the power y plus e to the power minus y. Then we can cancel 1 over 2, and we have e to the power y. We can write this one as 1 over e to the power y divided by e to the power y plus 1 over e to the power y. Let's add. This becomes e to the power y times e to the power y, which is e to the power 2y, y plus y minus 1, and denominator it is e to the power 2y plus 1. Here we have divided over e to the power y here also, so we can cancel them, e to the power y with e to the power y. So x is this quantity. Let's multiply this one both sides. So we have e to the power 2y plus 1 times x equals to e to the power 2y minus 1. So this becomes x times e to the power 2y plus x equals to e to the power 2y minus 1. Now let's collect all e to the power 2y terms together and other terms on another side. So we have e to the power 2y, this comes to left side, so it becomes minus e to the power 2y, and minus 1 x plus, so it becomes minus x. Let's take e to the power 2y common, so we have x minus 1. See, here the equation does not converge to quadratic equation. That's because here we have no term as e to the power y. If we had e to the power y, then we will solve the same procedure by using quadratic formula. Since we have e to the power 2y on both sides, we can collect the terms together and separate y from that. So what is e to the power 2y? That is, you can write this one as minus times 1 plus x divided by x minus 1, which can be written as minus 1 minus x. So e to the power 2y is 1 plus x divided by 1 minus x. Taking natural logarithm both sides, we have 2 to the power y as ln 1 plus x by 1 minus x. So what is our y? Y is 1 over 2 ln 1 plus x over 1 minus x. Our y is hyperbolic tan inverse. So hyperbolic tan inverse x is 1 over 2 ln 1 plus x over 1 minus x. In this way, you can prove for other 3 hyperbolic inverses. Sometimes without following this procedure also, you can find the logarithmic equivalent of inverse hyperbolic functions. Like, suppose we want to show hyperbolic sine inverse x as ln x plus x square plus 1 square root. See, if x equals to hyperbolic sine y, we have taken y as sine inverse x, sine hyperbolic inverse x, then x becomes hyperbolic sine y. So what is our cosine hyperbolic y? We know hyperbolic cosine y square minus hyperbolic sine y square. We know this is 1. If this is x, then x square is 1. So what is our hyperbolic cosine square? This is 1 plus x square. So hyperbolic cosine y becomes plus or minus 1 plus x square. Hyperbolic cosine y can never be negative. So we are left with 1 plus x square square root positive. So cosine hyperbolic y is 1 plus x square. Also we know cosine hyperbolic y plus sine hyperbolic y is e to the power y. And what is hyperbolic cosine y? This is 1 plus x square square root. This is our x. This is e to the power y. Then logarithm both sides, natural logarithm, we have ln 1 plus x square square root plus x is equals to y. Y is our hyperbolic sine inverse. In this way also you can find the logarithmic equivalent of hyperbolic inverses. At last we have other 3 hyperbolic inverses in their logarithmic equivalents. These are their domains. You can take this as an exercise and prove that indeed these are their logarithmic equivalents. If you have any question, then comment in the comment section. I will try my best to make a separate video on those topics. Till then, thank you.